Hello students. Today we will demonstrate the experiment of determination of subtransient reactance of salient pole alternator. This is the circuit diagram for that. So this is the alternator. In order to do the experiment, we are going to use only two windings which are connected across single phase AC supply. In between that, we have connected the lamp bank for the increasing the current, ammeter for measurement of current, and voltmeter for measurement of voltage for the armature, and across field winding we have connected the ammeter to measure the field current. So accordingly I have done the connections. I will explain you. First we will trace the connection. If you see the R phase I have connected to the lamp bank, so you can see this green color wire. Okay, so it is connected to the lamp bank over here. Okay, one phase I have used. Then from the lamp bank it is going to the ammeter, right? From the lamp bank to ammeter, so you can trace this from lamp bank to the ammeter. So ammeter which I have selected is of 0 to 5 ampere range. Okay, then from ammeter it is going to this red color wire. It is going to the R phase of alternator, right? If you see the circuit, from ammeter it is going to R phase, right? And then Y phase it is going to the neutral. Okay, so from circuit diagram you can trace Y phase is going to the neutral, right? Then the voltmeter is connected across R and Y, right? So voltmeter we have selected a range of 0 to 300 volt, and if you see I've connected it across this yellow color wire across R and this red color wire across Y over here, right? Then for the field winding, so these armature winding connections are over. This B phase is open, so I have not connected anything for this B phase, right? Then for the field winding, two ammeters we have to connect with the help of switch. So F1 is connected to switch off, switch to ammeter, ammeter to F2. So if you see, this is F1, it is connected, this yellow color wire you can trace, it is connected to switch off position. Then switch on position, this green color wire is connected to ammeter. This ammeter I have selected of range of 0 to 500 milliampere. And then ammeter second terminal, this black color wire you can trace, it is going to F2, right? Similarly for the second switch, so F1 of this red color wire, it is going to the another switch of position, and then switch second terminal of switch is connected to ammeter. Now this ammeter I have selected it of 0 to 100 milliampere range, and then this second terminal of ammeter is going back to your F2. Okay, so initially we will keep this 0 to 500 milliampere switch in on condition. 0 to 100 milliampere switch is in the off condition. Okay, now procedure is I will switch on the supply, then we have to switch on the load, and then this is the alternator, right? So whatever is this shaft of the alternator that we have to rotate so as to locate the direct axis and quadrature axis positions. Okay, so now I will switch on the supply. See, this is the observation table. Along direct axis we have to measure the value of voltage, armature current, field current, two readings for two different load conditions we will take down. Similarly along quadrature axis. Okay, so now I will switch on the supply. AC supply is switched on. Now I will switch on the load. See, load I have switched on, right? So see, the current is available. Now we have to locate the direct axis and quadrature axis positions. So first, in 500 milliampere ammeter is showing you some reading. 0 to 100 milliampere switch is off, so it is not showing the reading. Okay, so now if you see, we will rotate the rotor with hand clockwise. एकदम हळू फिरवा. Just wait. see madam, Ambarkar madam is rotating that rotor. I will show you the ammeter. Exam halo. See, the pointer is increasing, then again it will decrease. Rotate it again. बस थोड़ा उल्टा डायरेक्शन ला फिरवा नाही अजून उलटा फिरवा फिरवा थोड़ा हाँ बस yes बस yes. So students, you can we will note down the reading. So this is the direct axis position, because after this position your pointer is reverse coming back to its zero position. Okay, so now at this time I will note down the value of current. So that is for lower scale we have to select. So it is 2.35. Let us note down, right? Then if you see the current, field current, that is 145 milliampere, right? So field current is 145 milliampere. This is in milliampere, that you have to remember. Okay, and now the voltage we will measure with the help of DMM. I will measure the voltage across R and Y. So see, it is coming out as 62. Okay, so we'll note it down. The voltage is 62. Okay, now I will switch on more load. So first current is 2.35, no? Yes. So for this load, now we have to measure the quadrature axis value, right, for the same load. So what we will do is, again we will rotate the rotor with hand. Okay, bus. Okay, now see, this meter is showing you 0 reading, or above 0, but that current is not measurable, and hence what I will do is I will switch off this switch and I will close the switch of 0 to 100 milliampere, and that current you have to measure it in 0 to 100 milliampere range of ammeter. Okay, so my current measured is 3 milliampere. So for quadrature axis I can note down the first reading as current is 3 milliampere. Corresponding armature current is 2.2,